Hi everyone. Continue our lesson on chapter 5 waves. So now I will discuss on topic 5.6 interference of wave and also 5.7 electromagnetic waves. Okay, let's look at 5.6 interference of wave. Before we have discussed three phenomena of wave: reflection, refraction and diffraction. Now is the last one, interference of wave. Okay, what you should know about interference of wave. First, principle of superposition of waves. When two waves meet, the wave overlap or superimpose. The resultant displacement is the sum of individual displacement of the two waves. As we know, the displacement, maximum displacement is related to amplitude. Mean if two waves meet, overlap, it will produce new wave with a new amplitude. The amplitude of the waves is the sum of individual displacement of the two waves. Okay, as example, let's say the first wave coming crest. The amplitude is A, and then it will meet at this point, another wave, amplitude also A. When meet at this point, resultant displacement of the waves that meet here is equals to sum of displacement, meaning amplitude for this one will be A plus A. So the new amplitude is A plus A, which is equals to 2A, meaning it will produce new resultant amplitude 2A. So this one we call it interference. So you must know this one, principle of superposition of waves. And let's look at the important terms, something like coherent wave. Coherent wave, we have two waves like this. Okay, two coherent wave means the wave that produce same frequency, or wave that have same frequency or constant phase difference. Okay, when we talk about, let's say we have coherent sources. What is the meaning of coherence? Let's say we have coherent sources that produce wave S1, S2. This is the wave produced by S1. Okay, let's say I have another one, S3 here. Okay, for S1 and S2, when you check displacement of the wave at any time, let's say this point, T1 for example, T1. So both have same displacement and both are crest. When you check here at this point, both are trough, same displacement also. This one, both are crest, same displacement. Trough, same displacement. Crest, also same displacement. So S1 and S2, we call it in phase. Sama fasa. Okay, sentiasa sama. Okay, but you check S2 dengan S3, S2, S3, let's say at this point, crest, trough. At this point, trough, crest. At this point, crest, trough. Means the difference is crest and trough. What is the difference, crest and trough? This one is one complete wave. The distance for this one complete wave is lambda. If you measure between crest and trough, that one will be half lambda. So the difference is half lambda. So we check S2 and S3, the difference is always half lambda. Crest, trough, trough, crest. Okay, so we call it S2 and S3 constant phase difference. That's just a term, constant phase difference. Okay, itu maksudnya. So coherent sources, both are coherent. S1 and S2 are coherent. S2 and S3 also coherent because produce same frequency of wave and constant phase different or same phase also can. Okay, in phase pun boleh juga. Constant phase different tu sama lah. Kalau in phase tu maksudnya dia punya phase different dia zero. So always zero. So kita just take this one lah. Constant phase different. Okay. Okay. What is the meaning of interference of wave? Okay, it is a superposition of two or more waves from a coherent source of wave. Okay, the wave superpose or meet produce resultant wave. Okay, with amplitude equals to sum of individual displacement of two waves. So you must be able to state the meaning of interference. Okay, let's look at two types of interference. Just now we discussed about in phase and constant phase difference. Let's say the wave that meet in phase. Crest, mid crest, in phase. So the resultant wave or resultant amplitude of wave is equals to, let's say this one is amplitude is A, coming here is A, thus the resultant amplitude will be A plus A equals 2A. So this one, 2A, the amplitude. Okay, or we have trough, mid trough. Okay, the amplitude here also A, the amplitude here A. So combination or superpose will produce amplitude which is greater. So if the two waves meet or superpose and produce larger amplitude or maximum amplitude, we call it constructive interference. Okay, constructive, membina, become bigger. Okay, the resultant wave is stronger. So we call it constructive interference. Membina, interference, membina. Okay, for trough here, because this one is opposite direction to crest, we just put negative sign. So the amplitude is negative 2A. This one in phase. Let's look at for constant phase difference. Phase, a crest, mid, trough. Amplitude A. This one also amplitude is A. Both coming from coherent sources. When they meet at here, resultant amplitude or displacement equals to A minus A because A plus negative A, trough is negative. So A minus A equals 0, means cancellation will produce 0 amplitude of wave. Okay, so this one will become destructive interference. Okay, the two wave meets and produce minimum amplitude of resultant wave. Okay, so we call it destructive, memusnah. Okay, So we have two type of wave, two type of interference, constructive and destructive. Okay, if you have question, you can ask. You can write there. Okay, let's look at the uh, pattern of interference. We have S1 and S2, coherent sources. Okay, if we have a ripple tank, meaning we put a vibrator, parallel one, and then attach two dipper. We have same motor, connect to the same power supply, meaning frequency of wave produced by these two dipper are same. So this one S1, S2. When it vibrate up and down, it will produce this pattern. Okay, for S1, the blue color. For S2, the red color. Okay, so S1, you can see we draw here. The dash line represent the wavelength for trough. The solid line represent wavelength for trough. Means distance between two wavefront of crest, this is lambda. Same thing here. This is lambda. Okay, so both have same lambda because they have same frequency. Okay, let's look at what happened. You can see the wave produced by S1 and S2 meet at certain point. Look at the green color. For the green color dot here, put the green color there. The green color dot here, this one you can see is crest, mid crest. This one is trough, mid trough. Crest, mid crest. Trough, mid trough. So all these points represent constructive interference. Okay, constructive interference. The points here, we call it antinodes. Antinodes. The point, we call it antinodes. If you draw a line to join the antinodes, we call it antinodal line. Okay, antinodal line, the green color. Let's look at this side, the black color one. The black color, this is crest mid trough. Crest mid trough here. Crest mid trough. Trough mid crest. Okay, so constant phase difference. This one will produce destructive interference. And the point here, we call it nodes point. If you join the line of the line, if you join the points by using line, this line we call it nodal line. As you can see from here, we have blue and black line alternately. Berselang-seli, green, black, green, black, green, black, and so on. Okay. If you measure distance between two consecutive antinodal line, the green color, we can mark is X. Same thing, if you measure between two consecutive nodal line, this is also X. Actually, same length. Sama length, sama panjang. Okay. The formula represent for topic of interference or interference of wave. This one is interference of water wave. We can observe this pattern form on the screen of ripple tank. Separation between two sources is A, meaning if you have dipper, the separation here between the two dipper is A. Okay. Okay, now lambda is a wavelength. D is distance between the sources and the line where you measure X. Means X you can measure at anywhere. If you want to measure at this line, also can. If you want to measure at this line, You want to measure here also can. So the D will start from here. Okay, so up to you. Same thing. Okay, if you want to measure here, so D will be start from here. Okay, just measure at any point that you want, but make sure you define D correctly. Okay, so you have terms like X, D, A, and lambda. So the relationship between all the terms is lambda equals to AX divided by D. Okay, or you can just rearrange X equals to D lambda divided by A. Okay, there are formula, of course, you can calculate using the formula later. Okay, now let's look at next interference of wave, water wave. You observe this one, the water and floating ball. Okay, so concept of interference is applicable for all kind of waves. Water wave, sound wave, light wave, electromagnetic wave. Okay, so this one is water wave, same as what I discussed before. When crest meet another crest, combined amplitude is maximum, displacement maximum. Ini ialah constructive interference. When crest meet trough, combined amplitude is zero, displacement zero. So this is destructive interference. Okay, so you must be able to define this one, constructive. This one is destructive. Kalau nak ingat, construct, membina. Membina means become bigger. Destruct, memusnah, so become smaller. Okay. Okay, now look at interference of light. For light, the lambda is very small, as we know. Okay, so we use laser pen in this case. Why we use laser pen? Laser pen just produce one color. Okay, we call it monochromatic light. Okay, red color. Monochromatic light. Okay, meaning one color or one wavelength. As we know, colors sometimes combine. So this one is only one single color. For visible light, the white light can be dispersed to 7 colors: red, orange, yellow, green, blue, indigo, and violet. So all these colors, we call it monochromatic light. Red has its own wavelength, orange, its own wavelength, yellow, its own wavelength. So they have their own wavelength according to its color. From red to violet, lambda decrease. Means if you compare lambda for red, is longer than lambda for blue, something like that. Okay. Okay, for this interference, we need two sources. For light wave, we need two slits. So this one we form S1, S2. Separation between S1 and S2 or the double slit is A. So when light passes through the double slit, it will fall on this screen. Means light coming out from S1 and S2 will superimpose or meet, produce constructive interference, which is bright color, right? Destructive interference, which is dark. Okay, so you have bright, dark, bright, dark, bright, dark, and so on. If we use monochromatic light red, so you can see this is the red band, red, dark, red, dark, red, dark, and so on. So the distance between two consecutive red fringes, we can mark as X. The distance from the slit and the screen is D. We cannot see the point of intersection for the two waves because light wave we cannot see. If water wave, we can see the pattern using Ripple-Tank. For light wave, we cannot see. Same thing for sound wave. What you just observe is the effect that produced on the screen, okay, which is bright and dark fringes. Distance are constant. Okay, so a bit different compared to diffraction. Diffraction is just you have a very thick band at the center, and then towards the edges, the band become thinner. That one is diffraction. For interference, same length or same thickness of band. Okay. We have here bright fringes produced by constructive interference, dark fringes, destructive interference. So for this light wave, you also can apply the same formula. Okay, lambda length, wavelength of the light used, A separation of the double slit, X distance between two consecutive bright fringes or dark fringes. You can just take center to center like this. So this is X. For bright one also you can take center to center. Okay, so we apply the same formula. From this formula, if we use the same A and the same D and change the wavelength, the pattern that form will be represented by X. You can see lambda directly proportional to X. The longer the wavelength, the longer the value of X. Means if you use red color, you have this length, okay, X. If you use blue color, so the fringes will become closer because wavelength decrease if you change to blue color. Let's look at this one. Red, orange, yellow, green, blue, indigo, and violet. Lambda increases from violet to red. Means if you compare the wavelength of red, is longer. That's the reason why if you measure the distance between two bright fringes or two red fringes, this is X. If you change to green color, this is the X one. So lambda decrease, wavelength, lambda decrease, X also decrease. Okay. Here, the violet color. This is X. Okay. So shortest wavelength, smallest X value. Okay. So you just memorize the arrangement. Okay, the difference in the wavelength according to arrangement for 7 colors. This one. If you have question, then you can just write in the comment. Okay, interference of wave for sound wave. We apply the same concept. First, there must be coherent sources, S1 and S2. So these two loudspeakers are connected to the same audio signal generator, which produce sound. So mean the sound produced here, same frequency. So the sound wave also superpose and produce constructive and destructive interference. Okay, so there is two loud sound. The green color is loud. Okay, the X, red X here, is soft sound, loud, soft, loud, soft, loud, soft, loud. Okay, because as we know that the line, the antinodal line and the nodal line always coming alternately. Okay, berselang-seling. Okay, distance between two consecutive loud sound, X, or distance between two consecutive soft sound, also X. Okay, so the loud sound produced by constructive, destructive produced soft sound. Okay, so same formula that we can apply. Separation between two sources, A. The line where X is measured, distance between the loudspeaker and the line where X is measured is D. It means we can apply the same formula. Okay, wavelength of sound wave. AX divided by T. Okay. Okay, now let's look at next. Interference of sound wave in daily lives. Okay, water wave. Bulbous bowl generates water wave which interferes destructively with waves around home. This is for sheep. Okay, you can look at the bottom of the sheep. But we have the component okay, below there. Creates calmer water around sheep, less water drag. Lightweight anti-reflection lens that has coating that cause reflected light to have destructive interference that improve vision. For those who wear glasses, you don't experience reflection because it's already cancelled okay, by the coating. Sound wave, microphone and transmitter system in headphones in planes produces sound wave that cause destructive interference with surrounding noise. Okay, so you cannot hear a sound which is very loud coming from the engine, or maybe okay, or any sound coming in, you cannot hear. Okay, let's look at some exercise on this. Formula, remember the formula. If you cannot memorize, you can get from the list of formula. Okay, so lambda equals to ax divided by d, or you can just rearrange x equals to d lambda over a, same thing. Okay, let's look at here. Separation between two dippers. This is A, this is D, between two consecutive wavefront for crest, lambda, and this one is between two green color, the antinode is X, so we have here also X. Means we get 2X equals 0.4, so X is 0.2 meter. Calculate wavelength, so lambda equals to Ax divided by T. Check the unit. A is 5 centimeter. So 5 times 10 power negative 2. X is 0.2. I change all to meter. D 0.5. Okay, so we have the answer 0.02 meter. Lambda. Okay, for number 2, we have separation between two slits, 1 millimeter. Between two bright fringes, X. So we have how many X? 1, 2, 3, 4, 5. L equals to 5X. Means you need to find X first. This is D. Okay, formula X equals D lambda over E. Check the unit, millimeter, centimeter, nanometer. So unit conversion. D, let's say I use meter. So 15, 10 power negative 2. Lambda 650 times 10 power negative 9, because nano divide by A in millimeter, so it's 1 times 10 power negative 3. Okay, so we get the answer. Nine 0.75 power negative 5 meter. Okay, so you can check. Okay, this is a value of X. And then using the formula L, 5 times 7, 9.75. Okay, very small because lambda for light, very small, nearly 10 to the power negative 7. That's why your answer is like this. Okay, next B. Pick correct pattern if experiment repeated using blue light. Explain your answer. As we know, red light, if you compare with blue, red is longer than blue. Okay. Lambda and x, directly proportional. Means if lambda decrease, x also decrease. So you check which one showing smaller than this one. This is for red color. Means for blue should be shorter than this one. This is wrong already. This is diffraction. Okay, ini ialah diffract. Okay, mesti same thickness. Tak boleh tak sama thickness. Okay, so you can see which one is shorter. We get this one. Okay. Okay, next for number 6. You are involved in planning a hall that is suitable for events such as movie screening, conferences, and live theatre performances. Describe suitable features of the wall. Okay, so features of the wall and furnitures, power of speaker, position of speaker in front or behind, height of speaker placement, distance between loudspeaker, placement of seats. Look at the hall here, you can observe. Maybe you can imagine our school hall. Okay, for this one. Okay, for this one is for sections. Okay, modification. So you are given all this one more than 5. Okay, I will use this one for section C. So I will copy down all the aspect. You have 3 columns like this. Aspect, features of wall and furniture. From here you can get 2 points. You can find 2 points from here. Power of speaker, position of speaker. Okay. See the furniture first one. Okay, furniture. Okay, the furniture is made of wood. Okay. Reason. Wood does not cause reflection. Okay, furniture. else? We want to put wall of the wall. Covered with soft material. If you don't know, you just don't simply put. Also to prevent reflection of sound. Because if there is reflection, it will cause noise. Or the sound that coming to the audience will become not clear. Reflection. Or to prevent echo also can. Okay, next one is position of speaker. Okay, position of speaker we can put at higher place. Okay, we put the speaker at higher place because at higher place less obstacle. Okay, and then we look at next aspect. Oh, so position of speaker. Sorry, dia in front or behind? Microphone. Another one. should be behind the microphone. Not behind, sorry. The microphone is behind, sorry. Because we don't want the sound produced by microphone is interrupted by the speaker. Okay. Means the sound produced by mic first, and then the speaker produce. Okay. Position of speaker should be in mic to prevent interruption. Interruption of sound. Or prevent noise also can. Next, distance between loudspeaker. We want many students sit at the closer antenna line. Means we can put the student or the chair closer. We want to produce more antenna line. More antenna line means shorter X. How to reduce X? Okay, we know that X depends on d lambda over A. Relationship between X and A inversely proportional. If you want to decrease X, meaning we need to increase A. So distance between loudspeaker must be longer. Should be longer. Produce more constructive interference. Okay, so more students can hear the sound which is louder. Placement of seat. There is we cannot put it attached to each other. There must be a small gap between the chair. Okay. Or you can arrange it in the straight line. Same what you observe from here. Okay, means if this one is constructive, beside it is destructive. So just like there's a small gap between the chair. Between lines of chairs or line of seats to ensure seats placed at or along anti-northern line. Means constructive. So all students can hear loud sound. Okay, all students can hear loud sound. So this one, there are how many suggestions already? 1, 2, 3, 4, 5, 6. Okay, the more the better lah. Okay, so minimum should have 5 suggestions. 5 suggestions plus 5 reason or explanation in order for you all to get full marks. 10. Okay, that one is for the question, section C. Okay, if you have anything to ask, you can just write in chat. Okay, now we go to the last one in topic wave, which is 5.7 electromagnetic wave. You can refer to your textbook, page 220. So what is this electromagnetic? Electro is something to do with electric. Okay, magnetic, magnet. Okay, what is this electromagnetic wave? Okay, so wave made up of electric field and magnetic field that oscillate perpendicularly to one another. So you can see the red color is horizontal. This one is electric field. And then the one which is vertical, the blue color is magnetic field. So means that the angle between magnetic and electric 90 degrees. That's why we call it perpendicularly to one another. So when electromagnetic wave propagate, okay, these two magnetic field will vibrate. So it will represent the molecules of medium. That's the reason why for light wave or electromagnetic wave, it can travel in vacuum because it has its own magnetic field and electric field that able to vibrate. Okay. Characteristic of magnetic wave, transverse wave. Does not require medium for propagation, can propagate through medium. Speed 3 times 10 power 8 equals to speed of light in vacuum. Undergoes reflection, refraction, diffraction, interference. The four phenomena of wave. Okay. Arrangement of the electromagnetic spectrum. The spectrum consists of, on the left side here, radio, microwave, infrared, visible light, ultraviolet, X-ray, gamma rays. They are arranged actually according to wavelength and frequency. As we know, all the components of electromagnetic wave, they travel with same speed. Okay. Speed V equals speed of light, which means V is constant. From the formula of V equals to F lambda, if V constant means F and lambda is inversely proportional. So if lambda decrease from radio to gamma, means frequency increase from radio to gamma. Okay. Okay, the relationship is inversely proportional. Application of electromagnetic waves. Type of wave, the first one, radio wave, is a long distance communication, radio communication or TV. Millimeter wave machine to scan body of passenger at airport. Okay, use local TV and radio, TV3 and TV7, TV9. Okay. Wireless communication, Bluetooth, Wi-Fi, Zigbee, Z-Wave. Ini semua menggunakan radio wave. Microwave for international, meaning satellite. Okay, from overseas, live TV, FIFA. Ada pertandingan bola sepak international kan. So guna satellite. Itu ialah microwave. Mobile phone framework. Communication between electronic device. Bluetooth, Wi-Fi, Zigbee, Z-Wave. Okay. Ini application dia banyak kan. Detection of plane radar and speed trap. Cooking, microwave oven, GPS. Ini microwave. Infrared oven, you boleh nampak bila heating element tu dia become hot, then it glow, it produce infrared. Okay, so oven, grill, toaster, night vision, infrared binocular, camera, drying paint on car, treatment of muscle pain. Siapa yang pernah buat treatment ni? Okay, ni dia kalau pain, muscle pain, kalau ada bengkak dan sebagainya, dia boleh letak infrared. Remote control device, juga guna infrared. Visible light for sight, the light that we use to observe, to see things, we call it visible light. Ini untuk sight. Photography, photosynthesis. Laser light used to cut metal, measure length, send information through optical fibers. Ini ialah visible light. Ultraviolet, hardened tooth filling material. Kalau you pernah jumpa dentist, dia ada keluarkan satu macam lampu tu, warna macam purple sikit kan, ultraviolet. Detecting counterfeit money, duit palsu. Treatment of jaundice in baby, pun ada lampu jaundice yang warna purple tu. Purification of drinking water. Sterilization, surgical instrument and food. Insect traps. Okay, so ini ultraviolet. X-ray detect fractures or broken bones. Checking for welding connection. Timpalan welding, kalau ada sambungan pipe, boleh check balik sama ada dia perfect atau tidak. Back scanning at airport. Determine authenticity of painting, sama ada palsu atau tidak, painting tu authentic atau tidak. Gamma rays kill cancer cell in radiotherapy. Make food last longer in food industry. Sterilization of surgical and medical equipment in bulk. Okay, so ini gamma rays. Look at exercise. We have wave A, B, C, D, E, F, G. State the name for all the waves. Here you can see shorter wavelength, crest and crest lambda ini. Longer wavelength. Okay, arrange from shorter wavelength to longer wavelength must start from gamma. Okay, then X-ray. Then ultraviolet. Then visible light. Then infrared. Then microwave. Radio. Okay, make a funny sentence just to memorize the arrangement. Okay, you can state here A, gamma rays, B, X-ray, C, ultraviolet, D, visible light, E, infrared, okay, F, microwave, G, radio wave. Okay. Compare characteristic of the wavelength of D and E. Okay, you can see from gamma to radio, wavelength increase, frequency decrease. Okay. Wavelength of D and E, you compare. Lambda decrease, meaning wavelength of D is smaller than E. Okay. Frequency of B and D. B and D. So this one is longer frequency. This one is shorter, a smaller frequency. So frequency of B is more than frequency. Okay. Energy of C and F. C and F. Okay. So energy which is high frequency, so meaning energy of C is more than okay. A and E, same speed, meaning speed of A equals to speed of E. The one with high frequency here, high penetrating power. It's stronger compared to the one which is low frequency. Okay, number 2. Image shows laser reflecting panel on the moon. Laser light pulses from Earth will be reflected back to Earth by retroreflector. If the distance between Earth and Moon is given, calculate time taken for reflected laser to reach Earth. Okay, so this one is about reflection. Reflected. The speed is 3 times 10 power 8. Time taken for reflected laser to reach Earth. Laser light pulses from Earth will be reflected back to Earth by retro. Okay. Time taken to reach Earth balik, daripada hantar pantu balik lah. Okay, maksudnya 384 400 10 power 3 meter 3 times 10 power 8 T. So you cari T. Okay, you will get the answer in second. Okay, calculate frequency or UV ray that has wavelength of this one. Same thing, frequency ialah C divided by lambda, speed of light 3 times 10 power 8 divided by 300 nano, negative 9. So the frequency equals to 10 power 15 Hertz. Okay. Okay, number 4. Radar can be used to detect and locate objects. Waves are radiated out from radar into free space. Will be reflected by object. Object location can be obtained from the reflected wave. Based on the following characteristic, explain modification that can be applied to improve its efficiency. Okay, so we have how many aspects here? Okay, 1, 2, 3, 4, 5. Okay, there are 5 aspects. So we use the same method. I'm using the same method. Section C, section C. I want to use the same table, so I will rub off this one. Wait, I use another one. Yeah. Let's see, I just change this one to C. The question is section C. So this one should be ini you all punya suggestion. And here is the explanation. Okay, write the answer for this one. Size of parabolic. First, you can copy down all the aspects first. Size of parabolic, distance between signal receiver and parabolic dish, surface, location, type. Salin dulu aspek supaya tak tertinggal. Distance between signal and parabolic. signal receiver. Surface location. You all can try to write the suggestion and also reason. Okay. Size of parabolic dish must be bigger or larger to receive more signal. We can capture more signals. Okay. Distance between signal receiver and dish or receiver at focal point of dish. All signals reflected by the dish will be converged to the receiver. Okay, macam ni. Ini adalah receiver kat sini, focal point, focal point. So dia punya light signal coming all converge to focal point. So the receiver will receive maximum signal. Surface of parabolic dish must be smooth, okay, so that all signals is captured. Or we apply all the concept that we discussed on the topic reflection. Location of parabolic dish must be at higher place, okay, to avoid obstacle. Tak mau halangan, kalau kat atas kurang halangan. Type of wave use. This one we use for what? Okay. radar, locate object to improve efficiency. So we use microwave. Okay, can travel further. High energy. Boleh ya. Because for telecommunication, we have two type of wave, radio wave or microwave. Okay. To travel further, okay, for satellite communication, we use microwave because it has high energy compared to radio wave. High frequency compared to radio wave. Okay, so you write like this, 3 columns. Your answer can be seen clearly. So very easy to mark also. So easy to get marks. You can check whether you have complete points or not for the whole questions. Make sure if there is a reason stated in the above here, you cannot repeat it as a reason. Okay. Do you have any question? Ada soalan? Okay, those with me, if you have questions, means we have end already for chapter 5. Okay, I will end my session now. Okay, thank you for joining me. Bye.